the organization that you're representing. And then we move to Ruben with the Apprentice account, then Brian Hilson, Edwin, Faith Chepkoech, Monene, Jenga, then Nathan. So we can introduce ourselves in that order.
Okay, my name is Anthony Wamai. I represent Goldven Solution. So in Goldven Solution, we deal with SAP solutions, and also we deal with the integration to SAP as well.
Thank you, Anthony, and welcome. Let's go to Ruben.
Thank you, James. My name is Ruben Kiro. I work with Apprentice Cloud. I handle all their marketing processes in the digital presence. So I'm in charge of doing the blogs, organizing webinars such as these ones. And I have been the one who has been sending out those messages and notifications in those groups. Thank you.
Okay, thank you. Thank you so much, Ruben. Brian Hilson.
Yeah, hello. My name is Brian. I present Tech Voyage, which is a startup providing tech solutions. So I'm just here to try and learn how I can make my solutions better. Yeah.
Thank you, Brian. We will have Edwin, then Faith.
Hi everyone, my name is Edwin Moriemi. I'm the head of implementations and support at Apprentice Cloud. Thank you everyone.
Okay, thank you so much, Edwin. Let's have Faith. Faith Chepkoech.
Hi everyone, my name is Faith. I am not in any company, but I'm just here to see what's happening and to learn. I'm fresh in this industry. Thank you.
Thank you, Faith. Monene Jenga.
Hi everyone, I'm Peter Njega. I'm working with Radian, where we customize CRMs and we also do custom applications. I'm joining to learn about the team and about the developers. Thank you.
Thank you, Monene. We have Nathan Kabare.
Okay, so good afternoon, everyone. So as James has introduced, my name is Nathan, and I wear a couple of hats. So I'll try to be as brief as possible because I have quite a long job on JD. So first and foremost, I am a renewable energy consultant with Renow Energy. So in case any of you are interested in any renewable energy solutions across the spectrum from wind to biogas to solar, and Mkifika Bay, we can also do nuclear, wink. I'm the person to contact. Ideally, I am also a research consultant and project manager for social media management and digital marketing startup called Shop Kanairo that specializes in value addition services in digital marketing space, from SEO to content strategy management, website development, sentiment analysis on your social media platforms, and also comprehensive and in detail market audits and also research and brand advocacy. Aside from that, I am also a co-founder at Cultivate, which is a startup in the agri-tech space trying to revolutionize farming in the country, because we realize there's a very huge gap there where the average age of the Kenyan farmer is 65 years old. So we are doing a lot of good work in the agri-tech space to try and reduce that average age of farmers in the country. So aside from that, I am also the founder and MD for Engage 360, which is a research firm that conducts market research, in-depth scientific research, and also surveys for guys looking to invest into the continent, but need a guide on the landscape with regards to economic viability of whatever investment they are looking to make. And last but not least, I am also a sales and development executive for an AI startup called Patika Africa. And we've recently launched a very innovative AI solution for FMCG manufacturers and guys who handle orders or a large amount of orders in a day. And the solution is called Sanifu AI, which is essentially a sales clerk that automates or that automatically picks LPO orders from emails and WhatsApp in whatever format and pastes them onto your ERP platform, hence reducing clerical errors and human errors with a manual method of downloading the LPOs and transferring them onto your ERP platform. So ideally, if you know any manufacturers who are processing between 150 to 200 orders in a day, this is a very good solution for them that you can also put me in touch with. Otherwise, I am grateful to be amongst you guys today to understand more about what Apprentice Cloud does.
Okay, thank you so much, Nathan. You must be having 80 hours a day. That's quite some portfolio, and it's good.
You can't be a one-trick pony in Ruto's economy.
Exactly. Okay, thank you. Rose, you could introduce yourself, tell us your name, and also let us know the company that you present.
Thank you, James. Good afternoon, everyone. My name is Rose Wanjiko Wanjuru. I'm a software engineer at Spool Advisors. So we deal with agricultural insurance and currently collecting a lot of data. That is why the theme of this meeting is very relevant to me. I'm looking forward to learning how to build scalable software solutions.
Okay, thank you so much, Rose. I think finally we have Steve Nene. Steve, can you hear us? Okay, Steve introducing himself on the chat. Yeah, okay. So I had said earlier, my name is James Mwangi, CEO and founder at Apprentice Cloud Limited. As earlier said, we focus on custom environment, is building software from scratch. Is someone with feedback can help us mute so that we can hear each other. So I said at Apprentice Cloud, we focus on custom software development, also ERP and CRM installations. So today we'll be looking at building scalable software solutions, and we want to welcome all of us to this webinar. I want us to be to have us an interactive engagement where we ask ourselves, how do we build scalable software solutions, and are there examples of such software solutions in the world that we can learn from? So why does scaling matter, and why is it important? Number one, scaling is very important to keep us competitive. It gives us what we call a competitive edge. 70% of high growth companies have prioritized scalability to stay competitive. You realize that in the world that we are living in today, especially for companies that are keen on tech, it is very difficult for you to really be competitive if you don't try as much as possible to scale your business to reach as many users as possible. So scaling is not a matter of if, it's a matter of when, because every time we really want to keep that competitive edge for any business, we need to think about scalability. The other thing that that is important for us when scaling is handling growth, so that we can prevent bottlenecks as user base increases. For example, when M-Pesa was rolled out in Kenya, I hear that the first target number of users was 1 million users. So you realize that by then they were looking at onboarding only 1 million users who are Safaricom's customers then, and then later on we know that this business has scaled to almost more than 20 million users by now, meaning that we have been able to grow from that small user base of 1 million users to more than 20 million. And I know there are plans even by Safaricom to scale to the rest of Africa. So scaling does matter, and it helps us to handle company growth. The other thing that is important to know is the cost effectiveness. For us to be in a position to keep our costs optimized, we need to scale resources when they are necessary so that we can optimize the budget. Look at it this way. For companies that handle traffic for tours and travel, let's say, like Booking.com, Airbnb, they have what we call peak seasons, shoulder seasons, and low seasons. So during the peak seasons, you might need to have more resources to handle the traffic and to handle the number of users that are using that system at that time. For example, for a company like Airbnb and Booking.com, towards maybe November, December, they'll have maybe 3 times, 4 times, or even 5 times more bookings. So you don't want to be at a point where you lose business because the infrastructure that you have can't accommodate the number of users that are trying to access your site or to access your software product. You also don't want to be paying for 100 million users, whereas maybe you only need infrastructure to hold 20 million users in January when people are not going for trips. So because of that, you need to learn strategies on how to optimize and scale. And that's where this question on how and when to scale and the strategies that we employ in scaling come in. So for us to be cost effective, we need to know how to scale and when to scale our resources. The other thing, and the last thing, is to future-proof, to adapt to small and large shifts in user demand. We need to learn how to scale our applications. So what are the challenges in scaling? Number one is complexity. Systems become more intricate as they grow. So scaling needs to be handled in a way that systems are able to scale in the most convenient of ways. Let me give you an example. When M-Pesa was starting, I might use M-Pesa a lot in this webinar because I think most of us are familiar with that. I could also use Airbnb and Uber. So when Uber was starting, it was run in one town or one urban setting. But when it scaled outside of the US and went maybe to 20 or 30 or 40 other markets, that application became a little bit more complex because you have people asking for rides in Nairobi, other people are asking for rides in a place like San Francisco in the US, other people in New York, other people in London. And for such an application to really work, you need to handle that scalability in a way that is manageable. Otherwise, such a scale is a bit complex and it requires you to know exactly what to do. And that's why we have this discussion today to know how do you handle these complexities to make sure that the application is able to operate optimally without downtimes and giving the best service to the customers. The other thing is costs. 72% of businesses face cost challenges during unplanned scaling. So we need to plan. We need to anticipate growth. And in so doing, we are able to put in the resources and the plans and the strategies required when these applications scale. I'll give you an example, and maybe it's a classified example. There's a friend of mine who was working in for a customer site not mention the name because of NDA. And at the beginning, it was a site that was supposed to be an e-commerce platform for a big telco in Africa, in East Africa. And they did that project with PHP at the beginning, and they had an initial user base of around 1 million users. But they decided to run a campaign where you get a discount. I think they were giving, was it 30% or some cashback on, they had some sort of an offer going on. And the user base spiked from around 1 million users that they had anticipated to around 30 million users using the system at the same time. So what happened? The site crashed, and they could not even do what we call the M-Pesa IPNs, because people would pay with M-Pesa, and then the 8 seconds that supposed to we're supposed to get the instant payment notification would expire, and then they will not be able to really get feedback, and they will not be able to continue with their shopping on that site. And it became a big problem because customers, more than 100,000 customers, made their payments. The payments were deducted from M-Pesa, but the orders were never confirmed. And they really had to do a lot of work to make sure that that traffic is handled. Of course, it was a lot of chaos for the development team, but this happened because they didn't have what you call the planned scaling. They thought maybe we're just trying to optimize and run a campaign without knowing the implication of that campaign to the infrastructure they had at the moment. And later on, they used Kubernetes and other strategies, and they were able to scale that application. Currently, it can handle even to 100 million users using that at the same time. Let me give you another example that is closer home. You find that, especially for the government organizations, during peak seasons, their systems usually go down. An example is the KRA system. You find that people want to file their returns on, is it 30th of June or 31st June? Most of us file our returns on the last day, the last hour. And because of that increased traffic, most of these systems hang or they stop working. The same case with HELB and other government agencies. This happens because maybe, I'm not saying that these organizations have not planned the scaling, perhaps the systems are optimized to handle maybe 1 million users per a certain period of time, but you find that during these peak seasons, around 100 or 10 million people are trying to do the same thing at the same time. And because of so doing, the system can't work efficiently. So that's why it's important to plan and put strategies in place to handle softwares at scale. The other thing is security. When you're expanding softwares, security becomes a very, very big concern. So it's important to have that in mind, that this becomes a challenge when we are trying to scale softwares. So what are the strategies that we have to building scalable softwares? Number one is the microservice architecture. I know most of us might have come across this. Microservice architecture is an architecture that enables what we call independent scaling. Services are based or are built independently so that they can scale based on load and reduce resources waste. So for example, if you're looking at an Uber application, you can decide to have all the logins and all the signups to be handled by different services. So you have one service for login and another service for sign up. I'm not saying that that is how Uber is architected, but I'm just giving an example. Or you could have one service for sending emails, another service for sending OTPs. So that means that when the sign up service is down, people can still sign in because the sign up is a separate service. The sign-in is a separate service. Maybe sending of emails is a separate service. OTP is a separate service. And this offers what we call flexibility, because microservices are able to offer what we call tech flexibility, because each microservice can use its own language and framework. And they also have what we call fault isolation. I said that. Issues in one service don't bring down the entire application. So instead of building an application as a monolith, because the opposite of microservice is a monolith, where you have one application with all the modules and all the services built in and nested together. Such an application has challenges at scale because of fault isolation. So if one service is not working, other services will not work. So you find that maybe if sign up is not working, nothing else can work because the fault is not isolated. So it's important maybe for softwares that are being built to scale to have things like a microservice, to adopt a microservice architecture as opposed to a monolith. And I know these are conversations that really goes on the dev communities, whether we should go for microservice or monolith architecture. But I tend to believe each of these architectures have their place. I'm a strong supporter of both of them. I know sometimes, especially when you're building MVPs or you're building applications at a smaller scale, there's no need to have an overkill and do a microservice architecture. At that time, maybe you just need a monolith, and then you do your MVP and roll it out as fast as possible. But when scaling, or when you want to expand that software to be used by a larger user base, it's important to have a strategy in mind to accommodate or to build the application on a microservice architecture so that it can scale independently, have flexibility. You can decide you will use Spring Boot Java on one service, you will use PHP on one service, Python on another service. And this also gives you advantage because you don't need to only hire for one technology. You need people who know PHP or people who know Python. You could hire for Java, Python, and whichever language that anybody knows, or whichever stack they know, and whichever framework. And still, these techies can collaborate and build these services independently. That's what we're talking about when we say tech flexibility. The other strategy for scaling is something called cloud native development. So in cloud native development, we have three things. We have containerization, this use of Docker for consistent application to running in different environment. Then we have orchestration, where we have technologies like Kubernetes that automates deployment and scaling of application containers. Then we have dynamic scaling. So on cloud native development, this one leverages cloud computing to build, run, and scale applications. I know most of us are familiar with cloud computing. So on the cloud, it is possible to use cloud native tools to make your application scale on demand. I was telling you for companies like Airbnb, let me give Airbnb as one of the examples. During the peak seasons, let's say from November to December, they might experience 6 times or even 10 times more traffic than the shoulder and the low seasons. So there's no need to have very huge infrastructures to accommodate very many users that are only going to buy in December. So what do you do when you're faced by a challenge where your application is a little bit more seasonal, and these seasons can be predicted? So you employ what you call cloud native development. You leverage to build and run your applications on the cloud and then allow them to scale on demand. So technologies like Docker allow applications to run consistently across all environment, and orchestration technologies like Kubernetes automates deployment, scaling, and operations of applications across containers. So these technologies are used to make sure that you only scale when you need to. Then we have dynamic scaling that adjust resources in real time based on user demand. And you only pay for the resources only when you need them to avoid excess spending. I know for cloud providers like Amazon, they have what we call EC2. It's an elastic server where when you have more people visiting your site, then you're billed according to the number of visits that you had on that month. And when you have fewer people visiting your site, then your bill is a bit less. Just like electricity and all these other and water bills. So if you're not in that month, then your electricity bill is lower. If you're using more electricity that month, then your bill is higher. So that's how cloud native tools work to make sure that your application scales only when necessary. I'll give you a case study of Airbnb I had given you and told you earlier. It scales services during the peak seasons and leverages on cloud native tools to manage fluctuating demands so that they only pay for what their users have used. They don't need to buy big infrastructures for their site to run. They can scale on need basis. So that's the second strategy. The third strategy, is the database scaling approaches. So there are two main approaches. This is the vertical scaling. This is where you add power to an existing database. That is, you add CPU and RAM. Then there's what we call horizontal scaling. You distribute data across multiple databases, sharding and replication. Both of these strategies are critical, and there are situations where these strategies will be used. In some applications, vertical scaling is what works best. In other applications, horizontal scaling is what works best. Let me give you an example, a real life example. If maybe you want to tow a very huge load, you might decide to use a car that has a bigger engine. That is what we call adding power to an existing infrastructure. Or you might decide to use two cars with relatively smaller engines so that they can distribute their power and pull that load that you're trying to pull. Depending on the situation, each of these approaches can be used. So in some situations, you want to add the CPU and the RAM and scale that database, or you distribute that load across multiple databases so that you can scale horizontally. So what are the technologies? These SQL databases for structured data transactions, and NoSQL databases like MongoDB and Cassandra for flexibility in unstructured large-scale data. So if you have unstructured large-scale data, the best databases to use are NoSQL. If you have structured data and transactions running, SQL databases are the best to use in that particular case. But you could also use both. You can have NoSQL and SQL-based databases working on the same application, depending on what you're building. Let me give you a real-life insight. Facebook uses hybrid approach with MySQL for transactions and Cassandra, which is a NoSQL database for large distributed data across global regions. So that's a very good practical case where both approaches and both technologies have been used. Facebook has both MySQL and Cassandra for large distributed data across the global regions. Okay. So we had those three, the vertical, horizontal, and hybrid. And we give an example of hybrid, which is Facebook. They use the hybrid approach of using both. Then tools of scalability. So there are many tools. So for those of us who are developers, don't crucify me if I didn't put your tool on the list. I just put in the most popular. So for container orchestration, we have Kubernetes, we have Docker, we have Swarm for managing containerized apps at scale. Load balancing, we have Nginx, HA proxy to distribute incoming traffic across multiple servers. That is to avoid overload. For message queuing, we have RabbitMQ, Kafka, that help handle high volume data and reduce delays by asynchronously processing requests. Then we have other tools for monitoring and analytics. We have Prometheus for monitoring metrics and alerting, then Grafana for visualizing application performance data. Companies using automation and monitoring tools report up to 30% faster issue resolutions. That's a research that was done by DevOps and assessment. So if you are able to monitor on real time, if you are able to respond on real time, you are capable of resolving 30% faster. Don't wait for your users to call you for you to know that your database is down or you have issues with the traffic. Then we have real-world examples where scaling has been done. One is Netflix. Netflix uses microservice and AWS for the 238 million global users. You realize that when you're trying to scale infrastructure, you might be required to use more than one strategies. So for Netflix, they have used microservice strategy and also cloud native strategies to make sure that their 238 million users are served appropriately. Then we have Airbnb. They leverage Kubernetes and cloud computing for the unpredictable traffic. So still they're using containerization and the cloud-based, cloud-native tools to handle their traffic. Another example is Shopify. They support thousands of businesses with dynamic resource scaling. So Shopify strategies, they scale dynamically. That is a strategy they use to make sure that they serve all the businesses that they are running. So what's the takeaway for that? Successful scalability often combines multiple strategies and tools to balance performance, cost, and reliability. So how do we design for scalability? There are three approaches that I put down, but I know we could learn from each other. So number one, that I'll put forward as the best practice is prioritize modularity. Design systems as smaller independent components from the start. So if you are designing a system that you know will scale, it is important to make sure that you break it down to modules. Don't do everything in one place. It is not a one size fits all. In our community, where I come from in Kenya, that is the Kikuyu community. We are we are known for cooking a buffet in one pot. So you will have a meal that has meat in it, to have githeri in it, Githeri is a staple food in, in Africa. It has rice in it. It has potatoes in it, and it has soup and so many other things. So instead of doing that, it's important to separate concerns. You can cook that meat separately. Then you cook the rice separately. Then you cook githeri separately. If you have to put in fufu, for those of us who are from Nigeria, you put that separately so that somebody can scoop whatever they need and then combine that to one plate. So when building a software, prioritize modularity. Make sure that everything is broken down and every module is able to handle whatever work they're supposed to handle. This will help you also to transition to things like microservice very easily, because you can decide at the beginning you build a monolith, you do your MVP, you test it, then at scale you break down these modules to become microservices, and this one will help you scale very fast. The other thing that you need to do is you need to have regular optimization, continuously monitor system performance to address issues proactively. You should be very proactive. Don't wait for the systems to go down for you to act. It is important to monitor. For example, the case that I gave you where a friend of mine was building the e-commerce system for the big telco. They were able to solve that problem very fast because they were monitoring it on real time. So don't wait for the system to crash so that you can now put in the mitigation measures. It is important to anticipate. For example, you're designing for 10 million users. Anticipate that, then monitor, so that when you get 11 million users, you start thinking of the strategies to use to make sure that your system scales in the right way. Then the other thing is that you need to prepare for traffic peaks. Don't be caught off guard. Then the third thing is automation. Use automation to dynamically scale resources to reduce manual intervention. I know nowadays AI is the talk of the day. So there are AI tools that are able to help you to anticipate and scale resources automatically, so you can reduce manual interventions. And the cloud native tools also help you to anticipate traffic, and you handle the intervention and the mitigation measures so that you don't have to have manual interventions when problems come in or when your application is trying to scale. For example, I told you we have Amazon EC2. So if you build your application on top of Amazon's infrastructure, it is very easy to scale efficiently. Even Google Cloud, they have cloud native tools that will help you scale efficiently so that you don't have to have what we call manual interventions. So what is the future of scalability as we come towards the end of this webinar? So the future is serverless. Serverless allows automatic scaling based on demand without managing servers. So this is the serverless architecture, and it's predicted that 50% of global enterprises will use serverless architecture by 2025. So the serverless is offering what we call the future in terms of scalability, and it's anticipated that 50% of businesses will use serverless architecture by 2025. Then the other future that we have is edge computing. This brings data closer to the user for faster load times. Then, as I mentioned earlier, we have AI-driven load management. So this is the use of machine learning to optimize resources and predict demand. We all know that the future is in AI as far as tech is concerned. So there will be AI-driven management. Of course, I know there are tools that are coming up. I couldn't talk about them today because of time, but I think as we move along with these webinars, we will get to look at some of these tools. The key insights that we gather from today is that Gartner forecasts that 50% of global enterprises will use serverless architectures by 2025 to improve scalability and efficiency. So if you're looking at building scalable softwares, we can't ignore looking at serverless architecture, edge computing, and AI-driven management. I know I've talked for quite some time, so I will now open up this forum for us to also respond. I know some of us are also techies. We've been doing this in our companies. So if you have an insight, maybe there's something I've left, you can always feel free to mention. But I'll also open this forum to questions, even as we come to an end of this. We've not yet finished. I see some people are dropping. So please ask your questions, even as we near the end of this one. So you have our contact information over there. Our email is apprentice.cloud@gmail.com. LinkedIn is Apprentice Cloud. Our website is apprenticecloud.io. I also put in my phone number on the chat, just in case you need to have our phone number. That's my personal phone number. You can reach me through that number. So any questions? Rose, do you have any questions? You mentioned that you're working on, is it big data? You have some large volumes of data in your organization.
Yes, actually, we are currently working on scaling.
Okay.
So what we've done for now is have increase the number of servers to handle the load and distribute the load.
Okay.
But I don't know if you'll have another webinar to go into details on how we can manage to auto scale instead of having the instances running all the time.
Okay, so I think what we can do, we can link up and have a conversation with you on how to go about that. Because as I said earlier, you realize that situations are usually very different for every organization. So we could advise you on what to do. We can have maybe some sort of a discovery call after this. We don't have to wait for a webinar. We can set up a discovery call, get to know the specifics of what you're working on, and then we can advise you on the strategies to use, because sometimes you might need to combine different strategies. Apart from adding the number of servers, you might need to add other things or do other strategies to make sure that your applications scale efficiently. So maybe would you be open to have a conversation, maybe a discovery call, and have a discussion about that?
Sure. We can link up after this.
Okay, so I've shared my number. You can text me maybe on WhatsApp, and then we can pick up the conversation. Yes, Nathan?
I was just looking to inquire or maybe get some more insight on the architecture around serverless or the concept of serverless solutions and how data is handled in such a situation.
Okay, I think again, because of maybe the time, you could, I've shared my number on the chat. We can pick up a conversation and see how we can go to details about that. Do you have maybe a use case that you have?
As I was telling you guys, I am working on an agri-tech solution, and it's in hydroponics, smart hydroponics, and we are looking to incorporate a lot of data collection. So ideally, the concept of having a serverless database is quite fascinating to hear about or get more insight on it, so that I can also understand how I can incorporate it into my organization. Hence that question or that inquiry.
Okay, no problem. I think what I've done, I've noted it down. Text me on WhatsApp, and then I can give you a few slots for a discovery call, and then take you through in detail on what maybe you need to do, and also get to understand the context.
Okay, that's fine by me. Thanks.
Okay, thank you, Nathan. Anybody else with a question? Steve Washira, I think you're not in when we introduce ourselves. You can say hi and also give us some feedback. Steve gives us a feedback. Edwin will get ready. We want to do a Kahoot. Yes, Monene?
So my question is not per se on development or architecture. It has to do with how can I know when the next webinar is happening? Because someone shared the link for this. So how about the future?
Okay. Our intention is to have a webinar every Thursday, 2 to 3. We will try to keep the time on at 2 to 3. Last week we had it from 2 to 3, but this week, due to a colliding meeting, we put it from 3 to 4. Maybe you could tell us between 2 to 3 and 3 to 4, which is the best timing?
For me personally?
Yeah.
3 to 4.
3 to 4. And what about the rest? 2 to 3 or 3 to 4, which is the best timing? Edwin, you can get the Kahoot ready. I would want to run. Yes, Nathan?
I think I agree with Steve. 3 to 4 is more flexible on my end because of my schedule.
Okay, I see Rose also say 3 to 4. I think 3 to 4 works for quite a number of us. Then I will speak with the team. We have it from 3 to 4 every Thursday. We'll be sharing the link in advance so that we can prepare ourselves. 3 to 4 it is.
Okay, thanks.
Welcome. Steve. Oh, Steve dropped. There's somebody else. Nancy Mogoko. You could say hi as we near the end of this. And then I'm also expecting Edwin to share the screen for a Kahoot. A Kahoot is just a Q&A session where we recap on what we've learned today for like 2 minutes, and then we conclude this. Edwin, are you ready? Alex Oiganjo, you could say hi as well. And Adora IT Solutions, say hi. Okay. Edwin, you can take us through the Kahoot as we finalize. I think Alex and Adora are not in a position to say hi at the moment. Hi.
This is Josephine, just joined. Wanted to learn on scaling. Gichimu. It's been great to be here.
Okay, you're most welcome. Okay, Edwin, you can take us for the next 2 minutes, and we finish this.
Thank you, James, for the opportunity.
We can't hear you clearly, Edwin. You're breaking. You're not very clear. You're not very clear. Maybe I can explain because of time. Just go to your phones, open your browser, and type kahoot.it. Go to your phones, open your browser, and type kahoot.it. Take us to the first page that you can get the game code, please, Edwin. So type kahoot.it. Then to request for a pin. So on the pin, put the pin displayed on the here, that is 279 6928. Then you enter 2796928. I've put it on the chat, 279 6928. Then you put in your nickname. Mine is Gichimu. Then you are in on the game. You'll be given questions to answer. All the questions will be related to what we've gone through on this particular on this particular webinar. So give people just a minute to join. Time is not very good. Then we can start. I think Edwin, you can start the Kahoot so you don't spend too much time. Yeah, so you'll be given a few seconds to answer the questions. So you just select the answer. All questions are time bound, so you have to answer as fast as possible. Okay. Next. What language is number one? So your score is determined by how fast you answer the question. Okay. The man is number one. Let's go to the next one. Just have a few questions. Main benefits of microservice architecture. Okay. Let's see who are listening. Okay. Let's see who was listening. The man, still number one. The last question. Drum rolls. Let's see who is on the podium. Number 3, we have old language. Then Gichimu is number 2. Then finally number 1 is who? Squirrel. Wow, congratulations to Squirrel. Maybe you can give us the parting shot as we close. Who is Squirrel? Who is Squirrel? Okay. Okay. Maybe he's not in a position to speak. Who is Squirrel? Can you hear me? Okay, so I think let's bring it to a close. Thank you so much for coming in, and looking forward to connecting with all of us in the next webinar. I'm also looking forward to talking to you, Rose, because you had further questions, and Nathan, and see if it's possible for us to assist maybe in the challenges that you're facing in the current applications as you try to scale. All the best, and have a nice time.